Okay, so this is the third problem on projections of lines. A line AB 80 mm long is inclined to HP at 30 degree and inclined to VP at 45 degree. The end touches both HP and VP. Draw front and top views of the line and determine their lengths. Also measure the perpendicular distance of end B from both HP and VP. So this is the third problem. So as I said in the previous problem, you just check out the data. Minimum 5 data are required to solve the problem on lines. So here 80 mm is the first data, 30 degree and 45 degree. There are only 3 data are given. Okay, you need another 2 data. So those 2 data will be given by this. The end or one of the end touches both HP and VP. So here the coordinates of A or B is not given. Instead the coordinates starts with the reference line, that is XY, because the line XY belongs to both HP as well as VP. That is what the given information, and there is a small information here. This information is not given in the solution book, which is also called as the primer, but the university VTU has sent the errata where the corrections is noted there. This one, the end touches both HP and VP. So in the errata the correction is mentioned to include in this problem. Draw the top and front views. So you need to draw the top and front views of the line, and you need to measure the apparent distance of the line. So here a line AB 80 mm long. Directly a line AB 80 mm long is given. So this will be the true length. If it is given as the apparent length or in the top view or appears to be, then it will be the apparent length. Since it is directly given, it will be the true length. So true length of the line is given as 80 mm. Then it is inclined to HP at 30 degree and inclined to VP at 45 degree. Again here it is not given, like it is appears to be inclined to HP, appears to be inclined to VP as well. In the top view it is inclined to HP, in the front view it is inclined to VP, like that. It is not given like that. So it is true inclinations. So true inclinations, inclined to HP at 30 degree. Inclined to HP means it should be theta 30 degree, and inclined to VP. Inclined to VP you can measure in the top view, it is 45 degree. So it is 45 degree. And both a point touches both the HP and VP. So point A touches XY line. Fine. So to begin with the solution, first draw XY line, XY, and since we will be dealing with the first quadrant, we need to write VP and HP. VP and HP. Remember, if you do not write this information, you will lose marks. Okay. Now start with the solution. Here since the coordinates of A or B is not given, and since the information is given like the end touches both HP and VP, I will start with this point only. So this point will be the top view as well as front view of a point A. So I will write A here and A dash here. If I write A dash, it is the front view. If I write A, it is the top view. Front view and the top view. So the problem will start with this point only. So this point is the point which touches both HP and VP. Fine. Now from this point, draw a line 80 mm to 30 degrees to HP as well as 45 degrees to VP. So 30 degrees to HP, theta. Take a protractor, keep it here, draw a line which is 30 degrees to HP and cut the distance 80 mm. Take the compass, measure 80 mm distance, select A dash as center, then cut 80 mm Similarly, phi 45 degree, again keep a protractor inverted at point A, then measure 45 degree, so this will be 30 degree. Measure 45 degree and draw a line for 45 degree. This angle will be 45 degree. Similarly, measure 80 mm, because you know that true length will remain same for top view as well as the front view. For the views, the true length is not going to change. So 80 mm, take 80 mm in your compass, select A as center, cut 80 mm here. Okay. Once you get this point, you just draw a locus along that point. You just draw a locus along that point. So from this you need to get the apparent length now. So how you can able to get the apparent length? Once you write the true length, you just mark it the double line like this. So this represents true length. I will draw it using a different color to differentiate between the true length, apparent length, and the projector lines. So now this is the true length. We know that if you rotate the apparent length and project it towards other view, you will get the true length. Okay. So when a line appears to be parallel to xy line in one of the plane, you will get the true length of the line in other plane. This concept we know. So I need to make this line parallel to xy if it is apparent, or I need to project this up to xy and I need to make it parallel, then I need to rotate back to get apparent length. Okay. Since I am starting with the true length, I need to project it. I need to project it up to xy line because A point is here. So you need to project it up to this point, comes in line with point A. So this will be appears parallel to xy line, this line. So from this point, select A or A dash as center, this distance as radius. You just rotate it until this arc cuts the locus of point B. So here you will get a point. This will be the apparent length. Okay. Similarly, you just project a line from the true length here until it appears parallel to xy line. Then you rotate it back with radius A and this point. You rotate back until it cuts the locus of point B in the top view. Join these two, you will get the apparent length. Okay. The concept remains same. If it is apparent length, then rotate it until it appears parallel to xy line. From this you project it to get the true length, or if it is a true length, project it until it appears parallel, then rotate it to get the apparent length. Okay. It is one of the case 4 and case 5. You can remember case 4 and case 5. Okay. With the help of case 4 and case 5 studied in the previous session, you can able to solve this particular problem. So here this is A dash and this will be B dash, A and B, and this is B2, this is B1 dash, fine. So here draw top and front views of the line. It is over. We have drawn the top and front views of the line and determine their lengths. We need to determine the length. So I need to determine the length of the apparent length line, this one, as well as the length of apparent length line in the top view as well as in the front view. I need to determine this length. Okay. So in the solution book, the length is given as 57 and 69. This is 57 and this is 69. So if you draw it for the scale, you will get it as 57 in the front view and 69 in the top view. Then the angle alpha and beta 45 and 55, this you will get it as 45 degree, and this you will get it as 55 degree. Okay, so this is the complete solution of problem number 3. We'll move on to the problem number 4. Okay, so this is the problem number 4. The next problem, a line PQ 85 mm long has its end P 10 mm above HP and 15 mm in front of VP. The top view and the front views of the line PQ are 75 mm and 80 mm respectively. Draw its projections. Also determine the true and apparent inclinations of the line. So here you need to draw the projections and you need to determine the true and apparent inclinations like theta and phi and alpha and beta. We need to determine those inclinations. So what are all the given data? First count the number of datas: 85, 10, 15, 75, 80. So 5 datas are there. I have to solve this problem with the 5 datas. I must solve the problem. Yeah, the datas are enough. Now the line PQ 85 mm long. So directly the distance is given, line PQ 85. So it should be the true length. So true length of the line being 85 mm has its end P 10 mm above HP. The positions of point P is given here. In the previous problem, the position of point P was not given, but it is said that one of the end of the line is situated on both HP and VP. That means to say it is on XY line. But here the positions of one of the point of the line is given with respect to HP and VP. So end P 10 mm above HP. So P 10 mm above HP. Obviously it should be above HP and in front of VP because we will be dealing with only the first quadrant. Then 15 mm in front of VP. 15 mm in front of VP. Then the top view and the front views of the line PQ are 75 and 80 mm. So these two magnitudes 75 and 80 mm are associated with the views. Okay, it is given along with the views. So the top view being 75 mm and the front view being 80 mm. Therefore, since it is associated with the views, it should be the apparent length. Look at the difference between 85 and 75, 80. So this is not associated with any of the views, or it is not given like appears to be. Therefore, it should be true length. But here these two informations are given along with the views. Therefore, it is apparent length. So top view means the view, you are going to write it on HP and you are going to rotate it. So you will get it below XY line. Therefore, it is AB 75 mm. Then the front views. Front view means it is the view which is projected onto VP in the first quadrant. So it remains above XY line only. So above XY line means it is A dash B dash 80 mm. Okay, 1, 2, 3, 4, 5. 5 datas are given. So we need to solve the problem now with these 5 datas. Start with XY line. You need to draw XY line, X and Y, VP and HP. Okay. So start with the location of point P. Point P is 10 mm above HP and 15 mm in front of VP. 10 mm above HP. This is P dash. Then 15 mm in front of VP. This is P. So the distance of this is 15 and distance of the front view is 10. Once you locate the points, you just draw the locus and be careful while writing the lines. You need to maintain the thickness carefully apparent length should be more thicker and true length should be medium thick, then all other lines should be thin. Okay, for thickness also you will be deducting the marks if you vary the thickness. So apparent length should be darker and the true length line should be medium thick, and all other lines, these are all the dimension lines or the projector lines. These are all this is the projection line, this is the XY line, and this is the dimension line, and this is the construction line. So all these lines should be thin, because that doesn't represents the line. Only the lines which represents the original line, it should be darker. All other lines should be thin. Okay. Now how to move on? We know that true length is 85 mm. We know the points. So 85 mm. Take 85 mm in the compass. Select P dash as center. Draw an arc for 85 mm. But you will not be knowing the angle. If you know the angle, you can take angle and you can draw the line. But here the angle is not given to draw the line. So the true length may fall anywhere on this curve. This can be on here, on this point, on this point, on this one, anywhere it can be there. Then we know that AB, that is the apparent length in the top view, AB is 75. Okay. So 75, select P as center, draw 75 curve. A dash, B dash, 80, we know. So take P dash, we can draw 80 curve. Then what you are going to do now? Next. So this is the given information. With the given information, I can able to write only this one with the given data. Okay. But the line can be started from P and it can end up with any of the point on this curve. So a line can be anywhere on this particular curve. So which point you are going to select? It is not given here. But we need to use a concept here, concept of the apparent and true length. If a line appears parallel in XY line in one of the plane, then you will get the true length of the line in the other plane. This is the concept. So if a line appears parallel in one of the plane to the XY line, you will get the true length of other in the other plane. This concept you need to use. Now here it is the apparent length line. It is the apparent length line. So how you will get the parallelity? So when you take out the inclination like this one, so consider this as a line which is inclined to both VP as well as HP. Okay, how you will make it parallel? By rotating this, okay. So by rotating I can make it parallel to VP, or by rotating I can make it parallel to HP. So once it become parallel to one of the plane, then I can get the true length in the other. Okay, this is the concept. So I need to rotate it and I need to make it parallel and I need to project it to get the true length. This is the concept I know. Therefore, what I will do is, I have the locus of point P. Wherever the line falls on this curve, but if you try to make this line parallel, it should be at this point. If you try to make this line parallel, if you extend the curve of 75 mm, if you extend the curve for the radius of 75 mm, it will reach up to this point where it will appears parallel to one of the plane. So from this point, if you project, you will get the true length in the other. So if you just extend this curve, wherever this curve and this line cuts, that point will be the true length. This will be the true length. So this is the concept. So I need to measure 75 mm like this. This is 75 mm. Okay, I don't know on which exact point the other point Q falls, but I know the radius. I know the radius, so I can use the radius, and this point P, I can use the radius to make it parallel. That is what I am using. It is the constructional tips. So using this radius, I have made it parallel. From this point, if I project it, I will get the true length. Similarly, here it is 80 mm. This is 80 mm, P dash and 80 mm. I have the radius. I don't know on which point the exact apparent length Q point falls on this curve. I don't know, but I have the radius. So if I project it, if I try to draw the curve 80 mm, and if I made it parallel, it should be here, up to here, because P dash is here. This line is appearing parallel now. So from this point, if you project it, you will get the true length, and I know that true length is 85 mm. So select 85 mm in your compass, and select P as center, cut 85 mm, and join those 2 points. So this will be the true length. That will be the true length, where this distance will be 80 mm. This distance will be 80 mm. So I have used the radius to make it parallel. I have used the radius to make it parallel. That's what the concept. Now we have this point. You just draw a locus from this point, you will get other point. You just draw the locus from this point, you will get the other point. You just join those two, you will get the apparent length. So this is the apparent length. Okay. So this is P dash, and after solving the problem, you just crop the extra lines P dash and Q dash. This is Q1 dash, this is Q, and this is Q2. Okay, and just remember the thickness of the line. The line written on the yellow color is the apparent length, which should be darker. The line drawn with the color blue, it is true length, it should be medium thick, and all other lines written on white color, it should be thin. You need to maintain the thickness dark, medium dark, and thin. Okay, this convention you need to follow. Then in this problem, draw projections. I have drawn the projections. Determine the true and apparent inclinations of the line. True and apparent inclination. So this is the true inclination theta in the front view. This is the apparent inclination phi in the front view. This is the true inclination phi in the top view, and this is the apparent inclination beta in the top view. So we need theta, alpha, phi, and beta. So if you draw this problem to the exact scale, and if you measure, you will get the angle as 28 degree and 20 degree, alpha and beta 30 and 23, 30 degree and 23 degree. So if you draw this problem to the scale in your sketchbook, you will get these answers. So this is how you need to solve a problem where angles, when the angles are not given, only the distances are given. Okay. Okay, so the next problem, problem number 5. The top view of a line 75 mm measures 50 mm. The end P is 30 mm in front of VP and 15 mm above HP. The end Q is 15 mm in front of VP and above HP. So the information above HP is not given. Draw the projections of the line and find its true inclinations with HP and VP. So we need to draw the projections and we need to find the true inclinations, that is theta and phi with respect to HP and VP. So just analyze the problem first. The top view of a line 75 mm measures 50 mm. What does it mean? It means the true length of a line is 75 mm, okay, and the top view of the line 75 mm is measuring 50 mm. So the apparent length is 50 mm because apparent length will be shorter than the true length. Therefore, this is the true length and this is the apparent length. You just analyze. The top view of a line 75 mm measures 50 mm. Here, the top view is measuring 50 mm. Therefore, 50 mm is the apparent, 75 mm is the true length. So, true length is 75 mm. The top view means it will be below XY line, that is AB, or here it is mentioned as PQ. So, it is PQ, small letter P and Q, 50 mm. The end P is 30 mm in front of VP, end P 30 mm in front of VP, then 15 mm above HP, 15 mm above HP. The end Q is 15 mm in front of VP, so end Q is 15 mm in front of VP. And above HP, the information above HP is not given. So count the datas, 1, 2, 3, 4, 5, 5 datas are there. So I must solve this problem using these 5 datas. First of all, we need to start with the XY line. Draw the XY line with smaller thickness, XY, we need to write XY, then VP and HP. We need to start with this one. So now try to locate the points here. So in this problem, the position of point P is given 30 mm in front of VP, 15 mm above HP, and position of point Q is given with respect to VP. With respect to HP, it is not given. Okay, so locate point P first. It is 15 mm above HP. So above HP 15 mm. Point P dash. Since it is front view, P dash. 30 mm in front of VP. In front of VP, it will be below XY line, point P. So this is 30 and this one is 15. Once you mark the points, you just draw the locus of points. You just draw the locus of the points like this. Then we know that point Q is 15 mm in front of VP. 15 mm in front of VP. So in front of VP 15 mm means from the top view you can able to measure 15 mm from in front of VP, and you need to locate it on HP. Okay, 15 mm in front of VP, you need to locate it on HP, and if you rotate the horizontal plane, then it will come below the XY line. So 15 mm in front of VP means below XY line 15 mm. Since this is 30, it should be half. So with the half distance, you just draw one more line which should be 15 mm to the XY line, and this line is the locus of point Q. Locus of point Q. So point Q shall locate on anywhere on this line, point Q. Okay, this is the information given with respect to the coordinates of P and Q. Now these two, top view is 75 mm and the top view, not the top view, the true length is 75 mm and the apparent length is 50 mm. We know the apparent length and we know the true length, we know the locus. So take a compass, in your compass measure 50 mm distance. In your compass, select P point and cut 50 mm. Cut 50 mm. Similarly, take a compass and 75 mm. Measure 75 mm in your compass. Select P as center. Cut 75 mm. Then join those two. So 50 mm is the apparent length. So it should be darker. Apparent length, it should be darker. Then true length 75 mm, it should be medium thick. This should be medium thick. This is the true length. Now from this we need to get the true length and apparent length in the front view. So how to get that one? We know that true length is 75 mm. You just project this one. So this is the apparent length P and Q. This is P and Q2. Okay. So now look at the condition. So in previous problems the line was kept like this. It is inclined to VP, something like this, okay, towards the observer. This is the plane, this is the line, and you are the observer. So the inclination was given towards the observer like this, so that when you project this point onto the horizontal plane and this point onto the horizontal plane, and if you join those two points, then if you tilt it, you will be getting the view something like this. But in this case the inclination is given with respect to VP towards the plane like this, instead of towards the observer. Here in this problem the inclination is given towards the plane like this, so that if you project this point onto the horizontal plane, and if you project this point onto the horizontal plane, then if you join those 2 points and if you tilt it, you will get the inclination like this. So inclination something like this, not like this. Okay, you will get inclination something like this when the inclination is given towards the observer. So this, the inclination is given towards the plane. That is the difference between previous problem and this problem. Okay. Similarly, you need to take off the inclination to get the apparent length and true length, and to get the view like a line parallel appears parallel to XY in one of the plane. You need to rotate it, and you need to convert the inclination to both the plane into a standard case, either 4 or 5, the case number 4 or case number 5. That is what you need to do to get the true length. So here we know that PQ is the apparent length. Rotate PQ, make it parallel, then project it on to other plane to get the true length. So I am selecting P as center, PQ as radius. I am rotating this until it appears parallel. So P and this point is appearing parallel. So from this point I will project it. And I know that on this projection line true length will going to fall, because it is rotated and it is make it parallel. I made it parallel. So if a line appears parallel in one of the plane, I will get the true length in the other. So here I need to get the true length, and I know that true length is 75 mm. Take your compass, select 75 mm distance, select P dash as center, 75 you cut 75 mm here, you will get the true length. So join these two to get the true length. This is the true length. Now once you get the true length and this point P dash and Q1 dash, you just draw a locus. Just draw a locus with that point. Then you need to get the apparent length here. How to get the apparent length? So just project the true length onto the locus of point P dash in the front view, and from here take P dash as center and this as radius. You just rotate it back, make an arc, you will get the point wherever the arc cuts the locus. Here it is the apparent length. Okay, so this is how you need to solve the problem. And one thing you make clear, that the apparent length projector, this point that is Q dash and this point Q should fall in the same line. So these 2 points should fall in the same line if you draw it for the actual scale. So since here I have not drawn it to the actual scale, there will be a difference, but if you draw it to the actual scale, you should get these two parallel, and P dash P and Q dash should be in line. P dash P should be in line and Q dash should be in line, and that distance is called as distance between end projector. Distance between end projector. That distance is called as distance between end projector. Now you need to measure the inclinations, like this is alpha and this is theta, and then this is beta and this is phi. So if you measure it, once you draw it to the actual scale, you will get theta, alpha, phi and beta as theta 48 degree, alpha 50 degree, phi 12 degree and beta 17 degree. You will get this answer if you draw it for the scale. Okay, coming to the problem number 6. A line has its end A 10 mm above HP and 15 mm in front of VP. The end B is 55 mm above HP and line is inclined at 30 degrees to HP and 35 degrees to VP. The distance between end projectors is 50 mm. Draw the projections of the line. Determine the length, true length of the line and its inclinations with VP. So here distance between end projector is given. So distance between end projector, as I said in the earlier problem, it is the horizontal distance between the two projectors, A dash A, B dash B, or P dash Q, P dash P, Q dash Q. Distance between the end projector means the horizontal distance from two projectors of the points of a line. That is the distance between end projectors. So we'll start with the data. So 6 data are there. So we need minimum 5 data. Here 6 data are given. So we can able to solve this problem easily. So starting with the data, a line has its end A 10 mm above HP and 15 mm in front of VP. So I will start with XY line. X, Y, VP and HP. End A 10 mm above HP. So 10 mm above HP. I am going to write the locus of A dash. Then 15 mm in front of VP. So 15 mm in front of VP. A. I am going to write the locus. So this is 10 mm and this is 15. Remember, you need to maintain minimum 8 mm distance between the projector line and the dimension line, or between any two lines. Okay, 15 mm. The end B is 55 mm above HP. So end B is 55 mm above HP. HP means XY line. So from XY line it is 55 mm. So measure 55 mm from XY line and mark or draw a locus for 55 mm. So end B should locate on anywhere on this line. That is the locus. And the line is inclined at 30 degrees to HP. So 30 degrees to HP means in the front view, then 35 degrees to VP in the top view. So 30 degrees, take a protractor, keep it here, measure 30 degree and join the 30 degree line. Wherever that cuts the locus, that will be the B1 dash, where this is 30 degree. It is the given information. It is the given information. Here the length was not given. Instead the height of point B from HP is given and the true inclination is given. So true inclination 30. With the help of that I can able to locate this one. Then with respect to VP it is 35 degrees. So keep protractor inverted here. Measure 35 and draw a line you will be not knowing where to stop. You will be not knowing where to stop this line, because here it is the junction between the locus and this line. You have stopped the line, but here you don't know where to stop the line. So keep it as it is as of now. Now the distance between the end projector is 50 mm. So the distance between the end projector is 50 mm means the distance between this line and the projector of B measured from the apparent length line, not from the true length line. This is the true length, because this is true inclination. It is not associated with any views, or it is not given appears to be. So it is true inclination, therefore it should be true length. I will use blue color to represent true length. Okay, and for 50 mm you just draw one line, perpendicular line like this for the 50 mm. So this represents the distance between end projector. So the projector A should be here, therefore the projector B should be at 50 mm distance from projector A. That is what the distance between end projector. It is the horizontal distance between the projectors A and B. So B should fall on this line, therefore this should be B dash. This should be B dash, and if you join these two, you will get the true apparent length. You will get the apparent length. Similarly, you need to get the true length and apparent length here. So this is you will get the true apparent length here, but here you have got the true length. You don't know the distance, so you just rotate this A dash, B dash. You just rotate this, make it parallel, and from here you just drop a perpendicular. Wherever this perpendicular cuts this line, that should be the true length. Because you have rotated this one. Here it is appearing parallel. This one A dash and this point is appearing parallel in this view. Therefore you will get the true length in the other view. So this should be the true length. And once you get this point, you draw just draw a locus from this point. So this point will be B2. Just draw a locus. Wherever this locus and this line meet, the distance between end projector line meets, that will be the point B. And if you join A and B, that will be the apparent length. So this is the apparent length. Okay. So this is how we need to solve the problem. Now the unknowns, draw the projections of the line, determine the true length of the line. So I need to measure the true length. So measure the distance, true length from here to here. So your apparent inclinations will be alpha, this one, and here it is beta. And you can measure the apparent length from this point to this. Again it will be the apparent length. So this will give you the apparent length, this will give you the true length, and these two will give you the apparent inclinations. So this is how you need to solve the problem when the distance between end projector is given. Here the length of the line was not given, but the distance between the end projector was given. Okay.